We're going to have a look at isotopic mass, and in particular we're going to look at how we can take that isotopic mass and use it to calculate relative atomic mass. Relative atomic mass is represented either by RAM or AR. And in order to do this, you need to have the different masses, and you also need the abundance, that's how much of each isotope there is. And this is the calculation you're going to use. So let's start off with a basic definition. And definition of an isotope is something that has the same number of protons but a different number of neutrons. That means it's the same element because it has the same proton number or atomic number, but it's got different masses. And they basically behave exactly the same. There are some very, very slight differences when it comes to stuff like mass spectrometry you don't need to worry about. But they are essentially the same elements. They behave in exactly the same way. Now, chlorine has got 17 protons. We know that because it's number 17 in the periodic table. It's got two isotopes. So isotopes are 35 and 37. So that's the mass. Okay. Now, in order to find the number of neutrons, I therefore need to take the number of protons away from that, which is always going to be 17. And in this case, I'll have 18 neutrons. And in this case, I'll have 20 neutrons. So they're the same element, same number of protons, different masses. 37 is slightly heavier. And these are my isotopic masses. So they go into this box here. Now, if we use this, have a look at this as an example, we've got chlorine 35, and there's 75% of them will be chlorine 35. Now, if you have a look at the periodic table, the mass of chlorine is written as 35.5. Now, that's an average. And for every 100 atoms, 75 of them will be chlorine 35. For every 100 atoms, 25 of them will be chlorine 37. And we need to plug that into our equation. So my masses and my abundances are multiplied together. So that means I've got 35 times 75, and I've got 37 times 25. Okay, now this little sign here, this means sum of, so that means add them together. So that's what I'm going to do here. I'm going to add those two together, and then I'm going to divide it by the sum of the total abundances. Now the total abundances here are 75 and 25, so that's 75 plus 25. Okay. If I put that into a calculator, I'm going to get a whole range of different answers depending on what calculator I've got. So my advice here would be do this first, and then this, then add them together, then add those together on the bottom. GCSE, they'll pretty much always be 100. Okay, so you can normally get away with dividing it by 100, and then you divide that by whatever's on the bottom. So if I run through that, 35 times 75 gives you a value of 2625. Add that to the value of 37 times 25, which is 925. Divide it by 75 plus 25, which is 100. When you put those on top, that's 3550, 3550. There's a 0, not a 6. Divided by 100, it gives you a value of 35.5. That's how you should be writing it as a working out in the exams, because it makes it really clear where you've got the numbers from, including this here. However, you won't get it like that in an exam. What you'll get it more like is this. And the thing with this is you need to pick it apart. So if we have a look, magnesium has got 3 naturally occurring isotopes. I need to figure out what the abundance and the mass of those isotopes are. So in this case, with magnesium, 78% has a mass of 24. Just over 10% has a mass of 25. And 11% has a mass of 26. I'm going to go about it exactly the same way as I did before. So I'm going to do 78.7 times the mass, which is 24. I'm going to do 10.03 times 25, which is the mass, the abundance and the mass of magnesium 25, and I'm going to do 11.17 times 26, which is the abundance of magnesium 26, and then I'm going to have to add all those together and divide it by the 78.7 plus the 10.03 plus 11.17, which will equal 100. In fact, that will actually equal 99.9, I believe. So when we actually put those numbers into an equation, you will get in fact, let's change the colour back to blue so you can see where they're going. 1888.8 plus, and then 10.03 times 25 is 250.75, and then lastly the other one will come to, so 11.17 times 26 will be 290.42. Okay, I've added those together. They normally do equal 100. In this case, they actually equal 99.9. Okay, so now I'm going to have to add those together on top. So that will equal on top 2429.97 divided by 99.9. And if you plug that into a calculator, you'll get 2429.97 divided by 99.9. You'll get 24.32. So we're going to just round it to one decimal place, three significant figures, 24.3.